Imagine standing on a peaceful shoreline over 500 million years ago, as strange early creatures swim beneath the shallow seas, unaware that deep below the Earth's crust, an unimaginable force is stirring, waiting to reshape the planet forever. Roughly 511 million years ago, during the Cambrian period, the dawn of complex life on Earth, Australia was part of the vast southern supercontinent known as Gondwana. This ancient land was largely covered by shallow tropical seas, teeming with mysterious animals like trilobites, sponges, and the first reef-building organisms. The world was vibrant but fragile, a cradle for life's early experiments. Beneath this calm surface, however, something extraordinary was brewing. Deep in the Earth's mantle, under what is now northern and western Australia, immense geological forces were at work. These forces culminated in what we now know as the Kalkarinji Large Igneous Province, a colossal volcanic event unlike any ordinary eruption. Spanning an area larger than Greenland, over 2 million square kilometers, the Kalkarinji eruption released enormous volumes of basaltic lava through huge fissures in the Earth's crust. This was a continental-scale flood basalt event, where rivers of molten rock flowed across the landscape, building thick, layered plateaus of basalt hundreds of meters thick. But this volcanic inferno wasn't just a dramatic geological event. Studies have linked the Kalkarinji eruption to one of the earliest mass extinctions in Earth's history, occurring at the boundary between the early and middle Cambrian. It was a time when many early marine species disappeared, marking a reset in the trajectory of life. As we journey through the story of Kalkarinji, we will uncover how this ancient volcanic province formed, what made its lava chemically unique, how it impacted global climate and life, and the lasting legacy it left beneath the Australian landscape. A legacy still visible in the rocks around us today. To truly appreciate the scale of the Kalkarinji eruption, we need to rethink what a volcanic eruption can be. Unlike the stereotypical volcano with a towering cone and explosive eruption, the Kalkarinji event was a flood basalt eruption, a geological phenomenon where lava pours out through massive cracks or fissures in the Earth's crust, rather than a single volcanic vent. These fissures, some stretching hundreds of kilometers, ripped open the continent, releasing enormous volumes of basaltic magma sourced from the Earth's mantle below. The lava was low in viscosity, meaning it flowed like a thick river over the land, spreading widely and rapidly. The lava flows stacked one on top of another, with individual flows varying from 10 to sometimes over 200 meters thick. In places like the Antrim Plateau, the total preserved thickness of basalt reaches up to 1.5 kilometers, a staggering pile of molten rock built up over a geologically brief period. This volcanic province covers an area exceeding 2 million square kilometers, roughly the size of Greenland, making it one of the largest flood basalt provinces of the Phanerozoic eon, the current eon of visible life. The eruption likely lasted less than 1 million years, an incredibly rapid outpouring in geologic terms. This immense lava flood covered vast regions of what are now Western Australia, the Northern Territory, and Central Australia, burying landscapes and shallow seas beneath thick basaltic layers. But the eruption was not always peaceful. In some areas, especially where the lava met shallow seawater or groundwater, violent steam-driven explosions produced volcanic breccias, layers of fragmented rock welded together from explosive interactions. These violent episodes increased the likelihood of gases reaching the upper atmosphere, amplifying their global environmental impact. This catastrophic flow of lava reshaped the continent's surface, turning vast areas into dark basalt plateaus, some of which remain visible today as escarpments and cliffs. But perhaps more importantly, this eruption was a trigger for radical changes in Earth's climate and ecosystems. Changes. What sets the Kalkarinji flood basalts apart from many other volcanic provinces is their unique chemical fingerprint, a signature deeply etched into the rocks that tells the story of their ancient origins. The basalts are characterized by low titanium content, distinctly low Fe, and relatively high silica compared to typical mid-ocean ridge basalts. They belong to a group called low-titholytic basalts, known for their specific trace element features. One of the most fascinating findings is the enrichment of certain elements like rubidium, barium, thorium, uranium, and lead in the Kalkarinji basalts. These high concentrations hint at a magma source that was not just a simple melting of the upper mantle, but rather a mantle region that had been chemically enriched billions of years earlier by processes related to subduction, the sinking of oceanic crust deep into Earth's interior. Isotopic analyses of strontium, neodymium, and lead in these rocks further confirm the complex history of the magma source. The ratios suggest that the mantle under northern Australia was influenced by ancient Archean age sediments, making the mantle source composition quite distinct from other large igneous provinces worldwide. The magma likely originated at a depth between 5 and 10 kilometers within the crustal magma chambers, where fractional crystallization occurred. This means that as the magma cooled, some minerals crystallized out, changing the composition of the remaining melt. Yet throughout the eruption's lifetime, magma recharge kept injecting fresh magma into the system, maintaining a relatively homogeneous chemical signature across the province. Interestingly, despite the large scale of the eruption, the Kalkarinji volcanic rocks show limited signs of extreme alteration or contamination during eruption, an indication that the original chemical characteristics have been well preserved in the rock record. Understanding this geochemical uniqueness is crucial. It suggests that the mantle beneath northern Australia had a rich and long history, with ancient subduction zones leaving their mark billions of years before the Cambrian eruption. This event was not just a local volcanic outburst, but a window into the deep Earth processes that shaped the evolution of continents and mantle dynamics over vast timescales. The Kalkarinji volcanic eruption was not just a geological spectacle, it had profound and lasting effects on the environment and life on Earth. As the flood basalts poured out across the continent, enormous quantities of volcanic gases were released into the atmosphere, most notably carbon dioxide, CO2, sulfur dioxide, SO2, and methane, CH4. Scientific estimates suggest that the eruption emitted approximately 1.65 million teragrams, or trillion grams, of CO2, which represented about 1.7% of the entire Cambrian atmospheric carbon reservoir at the time. Such a vast injection of greenhouse gases could have led to significant global warming, disrupting climate patterns, and affecting ecosystems worldwide. However, the volcanic activity also released sulfur aerosols, which initially would have cooled the planet by reflecting sunlight back into space, a volcanic winter effect. This 1-2 punch of short-term cooling followed by long-term warming created wild swings in climate that were difficult for early Cambrian organisms to endure. The timing of the Kalkarinji eruptions coincides closely with notable declines in marine biodiversity, known as the early Middle Cambrian extinction events. Around 45% of marine genera, including many trilobites and reef-building species, vanished from the fossil record, marking one of the earliest mass extinctions in the history of complex life. Additionally, evidence from sedimentary rocks shows signs of ocean anoxia, oxygen-depleted seas, that further stressed shallow marine ecosystems. The eruption's intense lava flows also triggered explosive interactions, when molten basalt met shallow seas or groundwater, producing volcanic breccias and sending aerosols and ash into the atmosphere. There is also evidence that the heat from the massive basalt blanket led to secondary reactions underground, releasing additional methane and sulfur compounds from organic-rich sediments and evaporate deposits. These greenhouse gases further intensified climate change and ocean chemistry disruption. While scientists continue to debate whether the Kalkarinji eruption was the sole cause of these environmental upheavals, it is clear that this volcanic event was a major factor contributing to the early Cambrian ecological crises. It serves as an early example of how massive volcanic activity can alter Earth's climate and biosphere dramatically. The Kalkarinji eruption did more than just cover a vast area with basalt and cause environmental upheaval. It left a complex geological legacy that still shapes Australia today. The flood basalts formed thick, widespread lava blankets up to 1.5 kilometers thick in some locations, such as the Antrim Plateau. These layers of basalt created extensive plateaus and escarpments that can still be seen as dramatic cliffs, covered with iron-rich red soils, evidence of millions of years of weathering. Beneath the surface, the intense heat from the lava flows baked buried ancient sediments and organic-rich rocks, triggering chemical reactions that transformed organic matter into hydrocarbons. This process played a vital role in generating some of Australia's oldest known petroleum systems. Today, Energy companies study the region closely because of its potential for oil and gas exploration, a direct legacy of this ancient volcanic heat. Geologically, the Kalkarinji province is not a single continuous lava flow, but a collection of several sub-provinces, each associated with different sedimentary basins. These sub-provinces likely formed from separate volcanic centers but share a remarkably homogeneous geochemistry and age, indicating that they were part of one broad magmatic event sourced from a common mantle reservoir. The unique chemical signature of the Kalkarinji basalts, with distinct isotopic ratios, provides scientists a valuable window into the deep earth processes active more than 500 million years ago. It reveals how ancient mantle domains enriched by subduction processes billions of years earlier participated in massive melting events that reshaped the Earth's surface. Moreover, the eruption triggered lithospheric subsidence, creating broad, shallow seaways that facilitated the deposition of new marine sediments and fostered evolution in marine ecosystems after the volcanic event. Although much of the original lava flows are now buried beneath younger sediments, their influence remains tangible. In landscapes, in the geochemical fingerprints locked in rocks, and in the fossil and sediment records that reveal the dramatic interplay between geology and life. The Kalkarinji large igneous province, while less famous than some other flood basalts worldwide, stands as a testament to how deep earth processes can drive profound changes on the surface, altering terrains, climates, ecosystems, and even contributing to the birth of valuable natural resources. The story of the Kalkarinji large igneous province is an extraordinary chapter in Earth's history, a testament to the power of our planet's interior to shape surface environments, ecosystems, and even the course of life itself. As the oldest known Phanerozoic continental flood basalt province, Kalkarinji represents Earth's first major volcanic upheaval during the Cambrian, a time when complex life was just beginning to flourish. Covering over 2 million square kilometers with thick basalt flows, the eruption altered the landscape of what is now northern and western Australia on a continental scale. Importantly, this immense volcanic event coincided closely with the first great mass extinction of marine species in the Phanerozoic eon, wiping out nearly half of known genera. While the exact role of the Kalkarinji eruption in this extinction is still under scientific investigation, it is clear that its release of vast amounts of greenhouse gases, sulfur aerosols, and volcanic ash contributed to profound global environmental changes, climate swings, ocean anoxia, and disruptions to the carbon cycle. Beyond extinction, the Kalkarinji eruption profoundly impacted Earth's geology. Its unique geochemical fingerprint reveals a mantle source enriched by ancient subduction processes, offering invaluable insight into deep Earth evolution and mantle dynamics. The thick basalt blankets fueled hydrocarbon generation beneath the surface, marking the birth of some of Australia's oldest petroleum systems. Though overshadowed in popular awareness by later flood basalt provinces like the Siberian or Deccan Traps, Kalkarinji is no less important. It was Earth's first great volcanic inferno in a world of complex animals, and marked a moment when geology and biology began shaping each other in profound ways. Studying Kalkarinji helps us understand how large igneous provinces can influence climate, life, and geology on a planetary scale. It reminds us that beneath the calm exterior of continents lie forces capable of transforming both land and life, echoes of which are still found in the rocks and fossil record. As research advances, Kalkarinji continues to reveal secrets of our planet's fiery past and its enduring legacy in shaping the Earth we know today.